Let's jump into the quantum world. Get ready to open your mind to some of the most fascinating and mind-bending ideas in all of science. Hello everyone, Bill Nye here, and I'm thrilled to be your guide on this incredible journey. Today, we're talking about quantum computing, one of the most exciting frontiers in technology and science. Now, don't let the word quantum scare you. It might sound complicated, but together, we'll break it down and make it fun. Quantum just means we're looking at the world in a super tiny way, at the level of atoms and the little particles inside them, smaller than anything you can see with your eyes. Imagine you have a giant library with millions of books, and you need to find one specific sentence hidden somewhere inside. A regular computer would have to open every single book one by one, checking each page until it found the right sentence. That could take a really long time. But a quantum computer? It could, in a way, look through all the books at the same time, searching every page in a flash. It's like having a superpower for solving problems. This isn't magic, it's science. The rules of the quantum world are strange, but they're real, and they work. It's about using the strange and amazing rules of the quantum world to solve problems that are too big and too complicated for even the best computers we have today. Quantum computers could help us discover new medicines, solve complex puzzles, and even understand the universe better. We'll explore what makes a quantum computer so different from the laptop on your desk, and why scientists are so excited about them. We'll talk about their special powers, like being in many places at once, and how that changes everything we know about computing. Let's go explore the quantum world together. There's so much to discover, and it's going to be an amazing adventure. Consider this your personal invitation to the future. The world of quantum computing is waiting for you. Let's dive in. Let's start with what we already know, a classical computer. These are the machines we use every day, whether it's at work, at school, or at home. They're the backbone of our digital world, powering everything from emails to video games, spreadsheets to social media. These computers are amazing, but they think in a very simple way. They follow instructions step by step, processing information in a logical, straightforward manner. They use something called bits, which can either be on or off. Think of a bit like a tiny switch that can only be flipped up or down, representing a 1 or a 0. Now let's talk about the new kid on the block, the quantum computer. This is a machine that operates on the strange and fascinating rules of quantum physics. A quantum computer doesn't use bits, it uses qubits. Qubits are special because they can exist in multiple states at once, thanks to a property called superposition. A qubit is more like a dimmer switch, being on, off, or somewhere in between. Imagine a spinning coin. While it's in the air, it's not just heads or tails, but a mix of both. This both-at-once idea is one of the superpowers of the quantum world. It allows quantum computers to process a huge amount of information in parallel, rather than one step at a time. A classical computer walks through a maze by trying one path at a time, checking each possibility in sequence until it finds the solution. A quantum computer can explore all the possible paths in the maze at once, dramatically speeding up the process for certain types of problems. It's not just a faster version of what we have. It's a completely new way of computing, opening doors to problems we couldn't even attempt before. Quantum computers are designed to handle problems with a huge number of possibilities, like simulating molecules for new medicines or optimizing massive networks. They won't replace your laptop for writing emails or watching videos anytime soon. For everyday tasks, classical computers are still the best tool. Instead, they will work alongside our current computers to tackle the giant, messy, complex problems that are out of reach today. They are a special tool for special jobs, like having a microscope for tiny details or a telescope for distant stars. Quantum computers will help us see and solve what was once impossible. We mentioned the qubit earlier, but let's dive a little deeper into what makes it so special and why it's at the heart of quantum computing's incredible potential. A qubit is the basic unit of information in a quantum computer, similar to a bit in a classical computer, but with a fascinating twist. Scientists can use a single electron or a photon for qubits. These particles are chosen because they can be isolated and manipulated with extreme precision. These tiny quantum objects have special properties that we can use for computing, properties that are impossible in the everyday world. A qubit can exist in a combination of both states, like a spinning coin that is both heads and tails at the same time. It's in a state of superposition, holding the possibilities of both 0 and 1 together until we measure it, which is a truly mind-bending concept. This ability to be in multiple states at once gives quantum computers their massive processing power, allowing them to solve certain problems much faster than classical computers ever could. The number of possibilities doubles with every qubit you add, leading to exponential growth in computing power. A computer with just 300 qubits could hold more possible values at once than there are atoms in the entire known universe. That's almost impossible to imagine. Creating and controlling these qubits is incredibly difficult, requiring advanced technology and meticulous attention to detail. The slightest disturbance, like a vibration, a stray electromagnetic wave, or even a tiny change in temperature, can knock them out of their special quantum state. This is called decoherence, and it's a huge challenge for scientists, making quantum computers extremely delicate to operate. That's why quantum computers are often kept in super cold, heavily shielded environments, where every effort is made to protect these fragile quantum states and unlock the true power of quantum computing. Let's talk more about that amazing superpower we mentioned, superposition. Superposition is the idea that a quantum particle can be in multiple states at the same time. A qubit in superposition is like a radio signal. It's a mix of its zero state and its one state. This mix is described by probabilities. Before we measure the qubit, we can only say there's a certain probability it will land on 0 or 1. The act of measuring forces the qubit to make a decision. In the same way, when a quantum computer measures a qubit, its superposition collapses. The trick for scientists is to use the power of superposition before the collapse happens. A quantum computer can perform calculations on both the 0 and 1 parts of the qubit state simultaneously. If you have many qubits, the computer can perform a massive number of calculations all at once. This is called quantum parallelism. It's this ability to explore a huge problem space all at once that gives quantum computers their incredible potential speed advantage. If you thought superposition was weird, get ready for entanglement. Entanglement is a special connection that can happen between two or more qubits. When qubits are entangled, they become linked in a very deep way. Their fates are tied together no matter how far apart they are. If you have two entangled qubits, they form a single quantum system. What happens to one instantly affects the other. Entangled qubits behave in a similar way, but even stranger. In the quantum world, before you measure them, each entangled qubit is in a state of superposition. This instant connection is a powerful resource for quantum computing. It allows for more complex calculations and helps with things like quantum communication and error correction. Entanglement is what makes quantum algorithms so powerful. By creating complex entangled states among many qubits, scientists can create shortcuts to solve problems. It's a fundamental part of the quantum advantage, turning a group of individual qubits into a powerful, interconnected computing team. It's truly one of nature's deepest mysteries. So we have these amazing machines that use superposition and entanglement. Quantum computers aren't just for doing things faster, they're for doing things that are currently impossible. One of the biggest areas is in medicine and materials science. A quantum computer could simulate a new drug molecule perfectly. This could let us design new medicines in a fraction of the time. Similarly, we could design new materials for solar panels that are much more efficient. Another huge application is in optimization problems. A quantum computer could analyze all the possibilities at once to find the truly perfect, most optimal route. Finally, let's talk about artificial intelligence and machine learning. Quantum computing could supercharge AI. This could lead to much smarter AI systems. Imagine an AI that can understand language as well as a human. This isn't just theory. Real companies are building these machines right now. Two of the biggest players in the race are Google and IBM. In 2019, Google announced a major breakthrough. They claimed they had achieved quantum supremacy. Google's quantum computer, named Sycamore, has 53 qubits. Sycamore solved a problem in about 200 seconds. Google calculated that the same problem would take the world's best supercomputer about 10,000 years. IBM is another giant in this field. They've taken a different approach. They created the IBM Quantum Experience, a platform where anyone can run their own experiments on a real quantum computer for free. IBM is building a community and helping to train the next generation of quantum programmers. Both Google and IBM are constantly pushing the limits. They're in a friendly but fierce competition to build the first truly useful, large-scale, fault-tolerant quantum computer. The progress these companies are making is happening faster than many people predicted. Building and using a quantum computer is one of the hardest engineering challenges humanity has ever faced. There are two main problems that scientists are working very hard to solve. The first one is called error correction. As we've learned, qubits are extremely fragile. The slightest bit of noise can mess up their delicate quantum state. This is called decoherence, and it causes errors in the calculation. For a quantum computer to be useful, it needs to run for a long time without making errors. Scientists are developing clever ways to fix this. One idea is to use multiple physical qubits to create one, more stable logical qubit. The second major challenge is scalability. To solve truly world-changing problems, we need thousands or even millions of high-quality qubits. Scientists and engineers are working on new designs and new materials to make it easier to build larger quantum processors. Solving these challenges is the main focus of quantum research today. So, what does the future hold? The journey into quantum computing is just beginning. We are standing at a moment in history similar to the dawn of the classical computer age. The potential to revolutionize medicine, science, and technology is immense. We may soon see a world where diseases are cured with drugs designed perfectly at the molecular level. We might develop new materials that lead to unlimited clean energy. We could solve climate change by creating systems that efficiently capture carbon. It's important to remember that quantum computers won't replace the computers we use every day. Quantum computers will be specialized tools for specialized tasks. This partnership between classical and quantum computing will be incredibly powerful. The most exciting part is that the story of quantum computing is still being written. The future is not just coming. We are all building it together, one quantum leap at a time.